Welcome to History Explained, where we illuminate the past to better understand our present. I'm your guide to your daily journey through the past to empower the future. Today is Sunday, August 10, 2025. As we do every Sunday, we're exploring a revolutionary innovation that has fundamentally changed how humans understand our world and universe. Today, we turn our attention to the development of the telescope, the optical instrument that revolutionized astronomy and fundamentally altered humanity's understanding of our place in the cosmos. From its accidental invention in the early 17th century to modern space telescopes, this innovation has continuously expanded the boundaries of human knowledge. What makes the telescope particularly significant is how it transformed abstract philosophical debates about the universe into empirical science, providing evidence that revolutionized cosmology while establishing the foundation for modern observational astronomy that continues to reveal cosmic mysteries. So let's explore this transformative innovation, examining its origins, key improvements, and profound impact on scientific understanding and human consciousness. The telescope emerged in the early 1600s from advances in lens-making technology in the Netherlands. Dutch spectacle makers had been grinding increasingly sophisticated lenses for eyeglasses, creating the technical foundation necessary for magnifying distant objects. Hans Lippershey, a German-Dutch spectacle maker, is often credited with creating the first telescope around 1608, though the exact inventor remains disputed. The device, initially called a Dutch perspective glass, could magnify objects approximately 3 times their apparent size. News of this invention spread rapidly across Europe, reaching Galileo Galilei in Italy by 1609. Galileo immediately recognized the device's potential and began constructing improved versions that could magnify objects up to 20 times, far superior to the original Dutch designs. Galileo's telescopic observations revolutionized astronomy and cosmology. In 1610, he discovered 4 moons orbiting Jupiter, providing the first direct evidence that celestial bodies could orbit something other than Earth, challenging geocentric models of the universe. His observations of the moon revealed a cratered, mountainous surface rather than the smooth, perfect sphere described by Aristotelian philosophy. These discoveries suggested that celestial bodies were material objects similar to Earth rather than ethereal, perfect spheres. Galileo's discovery of Venus's phases provided crucial evidence for the heliocentric model proposed by Copernicus. The observed phases could only occur if Venus orbited the Sun rather than Earth, supporting the revolutionary idea that Earth was not the center of the universe. Meanwhile, Johannes Kepler improved telescope design by using 2 convex lenses instead of Galileo's combination of convex and concave lenses. The Keplerian telescope produced inverted images but offered wider fields of view and better image quality for astronomical observations. The reflecting telescope, invented by Isaac Newton in 1668, used mirrors instead of lenses to collect and focus light. This design eliminated chromatic aberration problems that plagued early refracting telescopes while enabling the construction of larger, more powerful instruments. Newton's reflecting telescope demonstrated that mirrors could produce superior image quality while being easier to manufacture in large sizes. This innovation established the foundation for modern large-scale astronomical observatories. Throughout the 18th and 19th centuries, telescope technology advanced steadily through improved optics, larger mirrors, and better mounting systems. William Herschel's discovery of Uranus in 1781 using a homemade telescope demonstrated how improved instruments could reveal previously unknown celestial objects. The development of photography in the 19th century revolutionized astronomical observation by enabling permanent records of celestial phenomena and long-exposure imaging that revealed faint objects invisible to the naked eye. Spectroscopy, the analysis of light wavelengths, transformed telescopes from instruments that merely magnified distant objects into tools that could determine the chemical composition, temperature, and motion of stars and galaxies billions of miles away. The 20th century brought electronic imaging sensors that replaced photographic plates with devices far more sensitive to light. Charge-coupled devices, CCDs, enabled detection of extremely faint objects while providing digital data that could be processed by computers. Radio telescopes, developed in the 1930s, opened entirely new windows on the universe by detecting radio waves emitted by celestial objects. These instruments revealed phenomena invisible to optical telescopes, including pulsars, quasars, and the cosmic microwave background radiation. Space telescopes eliminated atmospheric interference that limited ground-based observations. The Hubble Space Telescope, launched in 1990, provided unprecedented views of distant galaxies while confirming theories about cosmic expansion and dark matter. Modern telescope technology continues advancing through adaptive optics that correct atmospheric distortion, interferometry that combines multiple telescopes for enhanced resolution, and next-generation space telescopes that observe in infrared and other wavelengths. The telescope's impact extends far beyond astronomy to influence philosophy, religion, and human self-understanding. By revealing the vast scale of the universe and humanity's small place within it, telescopic discoveries fundamentally altered human consciousness and cultural perspectives. The instrument also demonstrated the power of technology to expand human senses and capabilities. The telescope showed how artificial instruments could reveal truths about reality that were completely inaccessible to unaided human perception. Scientific methodology was transformed by telescopic observations, which provided empirical evidence that could test theoretical predictions. This established observational astronomy as a cornerstone of the scientific method and experimental verification. The telescope's development illustrates how technological innovation often emerges from practical needs, in this case, improving vision, but can lead to revolutionary advances in pure knowledge that transform human understanding. Modern society continues to benefit from telescope technology through applications ranging from surveillance and navigation to medical imaging and manufacturing quality control. The optical principles developed for astronomy have found countless terrestrial applications. Today's discussions about space exploration, extraterrestrial life, and cosmology all depend on telescopic discoveries that began with simple Dutch spectacle makers over 400 years ago. The telescope remains fundamental to expanding human knowledge about our universe. Thank you for joining us for this exploration of the telescope's development and impact. Tomorrow, we'll be back with our This Day in History episode where we'll be examining the significant events that occurred on August 11th throughout history. If you enjoyed this journey through history, please like this video, subscribe to our channel, and hit the notification bell so you never miss an episode. We'd love to hear your thoughts on how telescopic discoveries continue to influence our understanding of the universe. Until next time, I'm your guide for History Explained, where we believe that understanding yesterday is the key to navigating tomorrow.